Welcome to the lecture series of digital electronics. As we discussed the binary 4-bit binary parallel adder in last session, where four full adder 1, 2, 3, and 4. These four full adder are connected in cascading. The addition of two binary number parallel implies that all the bits, the operation done by this circuit is AZ plus added. These two are added and generate the result sum 4-bit and carry output of the final stage, and input is carry input of the first stage. Okay, so here the agent and added are available at the initial stage for the competition at the same time. So as in any combination circuit, the signal must be propagated through a gate. Suppose here I input these two provide. So through the gate, some circuit, full adder circuit is that here, and it generates the output. So this gate propagation, the total propagation time is equal to the propagation delay of a typical gate times the number of gates available in the circuit. Suppose here in full adder circuit, exclusive or two XOR gates are there. So total propagation delay time is the double of 2 times of XOR. Okay, for the sum output. And for carry output, 2 AND gate plus 1 OR gate. 3 gate delay time is required to propagate the carry C2. So today we will discuss about this carry propagation. The longest propagation delay in a parallel adder is the time it takes to carry propagated through the full adder. Okay. Suppose here C2 is generated after 3 gate time period. C3 is generated after 3 plus 3 is 6. C4 is generated after 9 and C5 is after generated 12 gate delay time period. Okay. So the longest propagation delay in this parallel adder is the time it takes to carry propagated through full adder. Since each bit of the sum output depends on the value of input carry also. The S2 is depends on C2 also, while S3 depends on C3 and S4 is also depend on C4. Okay, so the since each bit of the sum output depends on the value of this input carry, the value of Si is in any given stage, the adder will be it is steady state final value after the input carry to that particular stage has been propagated. Consider here the output S4. Okay, let us consider this S4. So input A4 and B4 is steady at the initial stage as soon as the input is applied to this adder. But this is the already given the input, but input carry C4 does not settle its final steady time until the C3 is available. C3 is not C3 is not a stable input up to the previous stage. Okay, so all the carry input is depends on the previous stage. As I already said that the input carry C4 does not settle the final up to the C4, and then C4 is stable depends on the C3. C3 is depends on C2 and C2 is depends on C1. So C3 has to wait C2 and down to C1. This thus only after the carry propagated through all stage, the last output S4 and C5, S4 and C5 settle to their final steady state. The number of gate level for this carry propagation can be found from the circuit of the full adder circuit. Okay, let us take the simple one stage of full adder circuit. this is the full adder circuits is there, where two XOR and two AND gate and one OR gate is there. So here, this circuit is derived from the typical in the equations. The input and output variable use the subscription I. Okay, I we use here. I is the particular stage. I stage. The signal at PI and GI. PI is we defined here two signal of the half adder output. So PI and GI settle to their steady state value after the propagation through respective gates. So this PI and GI is not depends on previous carry. Remember that thing. It is only depend on the current stage input agent and added values are there. So PI and GI settle to their steady state value after the propagation through a respective gate. PI is set by after one XOR gate time. GI is set after one AND gate time. These two signals are common to all full adders and depends only in input agent AI and added bits BI. The signal input carry CI to the output carry CI plus 1. CI to CI plus 1. Propagated through AND gate and OR gate. Okay. This is propagated through AND gate and OR gate is there. So, which consists two gate level. The carry input CI to CI plus 1. CI to CI plus 1. Two gates delay is there. Which one? Okay, AND gate number 2 plus OR gate number 1. This two gate delay is to generate the CI plus 1 from the CI. If there are four full adders, as in discussed, four full adder, so the output carry C5 have a 2 into 4, 8 gate delay. As I already explained in the previous circuit, from C1 to C5, there is 8 gate delay time period will be utilized or propagate. So the total propagation time in the adder will be propagated time one half adder gate plus 8 gate level. Okay, so here we have to add one half adder circuit gate because it depends on this GI also. So GI is generated by one half gate delay time. The carry propagation time is the timing factor on the speed with the two number of are added in parallel. Although the parallel adder or any combinational circuit will always have a same value at in output terminal. The outputs will not be corrected unless the signals are given enough time to propagate it through the gates connected from input to the output side. Since all other arithmetic operations are implemented by successive addition, the time consumed during the addition process is very critical. An obvious situation or solution for the reducing the carry propagation process is very critical. A solution for the reducing carry propagation delay time is employ faster gates with reduced delay. But the physical circuit have a limit to their capability. Another solution is to increase the equipment complexity in such a way that the carry delay time is reduced. There are several techniques for reducing the carry propagation time in parallel adder. The most widely used technique employs look ahead carry generator. Look ahead carry generator. Consider this circuit. Okay, consider that circuit. Let's first erase that everything. So here the circuit circuit shows that two XOR gate generate the full adder and carry is also generated as already discussed, that the AND gate and OR gate and one half adder circuit, delay is required for each circuit. So consider the circuit here. We define one new binary variable. Which one? One is the this carry generator PI. This one, the half adder circuit output. This one PI. And GI is known as a carry generator, GI, for each stage. I stands for 1, 2, 3, 4 for 4-bit adder. So PI is the AI exclusive or BI, and while GI is the AI ended BI. The output sum and carry can also be expressed in terms of PI and CI. SI is PI XOR with previous carry, while CI plus 1 is carry generator plus PI into CI. So GI, we can say that carry generator, and it produced the output carry with both AI and BI are 1, regardless the input carry. While the PI called carry propagated because it is time associated with the propagation of carry from CI to this per propagation time. So propagation time CI to CI plus 1. Now from this function, each stage like a C2, C2 G1 P1 C1, C3 G2 P2 CT. So here we are substitute this C2 value here. Okay, C2 value from the equation number 1. So we got that G2 plus P2 G1 plus P2 P1 C1 is the C3. While the fourth stage carry 4 is equal to G3 P3 C3 as per the previous equation. Substitute the value of C3 from the equation number 2. So we got G3 P3 G2 P3 P2 G1 and P3 P2 C1 is there. Since the Boolean function for each output carry is expressed in sum of product term, these all are sum of product term. Each function can be implemented with one level AND gate followed by an OR gate. Okay, this is SOP means one level AND gate, first level, and second level OR gate. Because it is in terms of a sum of product term is that for C4, for C3 and for C2. So the three Boolean function we obtain are implemented in the look ahead carry generator. This circuit is known as called as a carry look ahead generator. Here, remember that thing, the C4 does not have a wait for C3 and C2 to propagate it. Okay, because the now C4 is depends on G3, P3, G2, P1 and P2 and G1. Only C1 is there. So no, there is no required to wait C2 and C3 and C4. Parallelly, it is propagated. Similarly, C4 is propagated at the same time of C2 and C3. The construction of 4-bit parallel adder with look ahead carry scheme generator. This is the circuit C4, CT3, C1. Now what we'll do, we will make here the carry look ahead generator that this is a half adder circuit. Okay, every stage have a one half adder, and the output of this half adder is generated parity generator and propagator. This is propagation and G1 P1. An internal circuit as per the previous. This is the internal circuit diagram. So each some output require two exclusive OR gate and one output of the first exclusive OR gate which generate the PI and GI for each stage, which and generates the GI available. All the PI and GI generated in two-level gate circuit only. The carries are propagated through look ahead carry generator and applied as input to the second exclusive OR gate. After the P and G is generated, which is generated C2, C3, C4. Okay, C1 is already input carry. So After the P and G signal generator settle into their steady state, all the output carry generated after a delay of two level gates. Thus, the S2 through S4, S2, S3, S4, and S1. But we are S1, we can directly take it. It is a carry input with plus PI, P1. Directly this P1 is here, first page. So all output carries are generated delay two level gate. Thus S2 to S4 is equal propagation delay time. All have a equal propagation delay time. P delay is equal. And how much? Okay, the two level circuit for the output carry C5. This circuit can be easily derived from the equation substitution based method as done in above. And it's require two gate delay plus whatever the gate particular delay time. So here two level circuit, two level OR gate. So 1, 2, 3, 3 and plus 1. 4 gate delay. So it reduce more than half time compared with original circuit. Okay, this is called as a 4-bit full adder look ahead carry generator. Remember the thing here, how much delay time is required? So level 1, all have a same time output is generated. So one level circuit, this is two level circuit, and this is another one level. So 1 plus 2 plus 1, 1 plus 2 plus 1, 4 gate delay is required to generate S4, S3, S2, S1, all have a require 4 gate delay. While in the previous stage, we calculated its require here 8 gate delay plus 1 half adder. So more than 100% times means we can reduce here the very big time period with the help of look ahead carry generator circuit. The same circuit is also useful for the 8-bit or 16-bit. At that time, 8-bit and 16-bit adder, the circuit is very important to generate less delay time for the fast operation, as well as power consumption is also reduced as per compared with the traditional full adder circuit. So this is the typical look ahead carry generator, and ready-made IC is available. The IC number is 74182. It is implemented with AND or invert gate. It has a two output G and P to generate the C5. C5 is equal to G plus PC1. I hope is it making sense how the look ahead carry generator can reduce the overall delay time. It is less than half time period can be reduced compared with the ordinary or traditional full adder circuit. Have a good day.